If you find this video helpful, please like, subscribe and press the bell icon for notifications. Hello guys, for today our topic is metric equations. But before that, let's review vector equation, which is C1v1 plus C2v2 plus up to Cn is equal B. Or we can say that it is a linear combination of v1, v2, v3 up to vn is equal B, where v1, v2, v3 up to vn and B are vectors, and c1, c2, c3 up to cn are some unknown scalars. So now let vectors v1 is equals to a1 b1, v2 is equals to a2 b2, and similarly vn is equals to an bn. Then this vector equation will become c1 times a1 b1 plus c2 times a2 b2 plus c3 times a3 b3 plus up to cn times an bn is equals to b. Or c1 a1 c1 b1 plus c2 a2 c2 b2 plus c3 a3 c3 b3 plus up to cn an cn bn is equals to b. Now add corresponding terms and we will get c1 a1 plus c2 a2 plus c3 a3 plus up to cn an, and c1 b1 plus c2 b2 plus c3 b3 plus up to cn bn is equal b. Now if we take a matrix A such that its first row is a1 a2 a3 up to an, and second row is b1 b2 b3 up to bn, and then multiply it with x, that is c1 c2 c3 up to cn, then ax is equal to a1 a2 a3 up to an b1 b2 b3 up to bn times c1 c2 c3 up to cn. Now multiply as we multiply in matrix. So ax will be c1 a1 plus c2 a2 plus c3 a3 up to cn an, and c1 b1 plus c2 b2 plus c3 b3 plus up to cn bn. And if we compare equation 1 and 2, then we can see that this is ax. So from first and second, we can say that ax is equals to b, and this is the matrix equation. This is in the form of matrix equation, where each column of A represents a vector. So A is equals to v1, v2, v3 up to vn, and x is equals to c1, c2, c3 up to cn. This is m into n order, and this is rm, where m rows in a matrix. So c1 times a1 b1 plus c2 times a2 b2 plus up to cn times an bn is equal b, and this is in vector equation form. So a1 b1 a2 b2 a3 b3 up to an bn times c1 c2 c3 up to cn is equals to b, where this is vector v1, and so this column is v1. Similarly, second column is v2, third column is v3, and similarly this column is Vn. So we can write it as V1, V2, V3 up to Vn times C1, C2, C3 up to Cn is equal B, where this is A, matrix A, and this is X. So this is in the form of AX is equals to B, and this is matrix equation form. Therefore, equations 2x minus y plus z is equals to 1, x plus 2y minus z is equals to 2, minus x plus 2z is equals to minus 1 can be written as 2x minus y plus z is equal to 1, x plus 2y minus z is equals to 2, and minus x plus 2z is equals to minus 1, and this is in system of linear equation form. It can also be written as 2 minus 1 1 1 2 minus 1 minus 1 0 2 augmented by 1 2 minus 1, and this is in augmented matrix form. And similarly, we can write it as x times 2 1 minus 1 plus y times minus 1 2 0 plus z times 1 minus 1 2 is equal 1 2 minus 1, and this is in vector equation form, where this is C1, this is V1, this is C2, V2, C3, V3, and this is B. So we can write C1, V1 plus C2, V2 plus C3, V3 is equals to B, which is the representation of a vector equation. Now, these equations can be written as 2 minus 1 1 1 2 minus 1 minus 1 0 2 times x y z is equal 1 2 minus 1, where this is matrix A, this is X, and this is B. So it's in the form of AX is equals to B, which is in matrix equation form. So this is a matrix equation. So the linear equations can be written as matrix equation, vector equations, augmented matrix, or system of linear equations. So if we multiply a matrix 2 3 1 2 minus 1 1 0 2 with a column matrix 1 2 3 4, we can do it in two ways. So first method is just multiply the first row with the column matrix, and then the second row with the column matrix, and we will get 2 plus 2 minus 3 plus 0, 3 plus 4 plus 3 plus 8, which will give us 1 and 18. Now for the second method, we know that the first column is V1, second column is V2, third column is V3, and fourth column is V4, and this is C1, C2, C3, C4. So we can write it as C1 V1 plus C2 V2 plus C3 V3 plus C4 V4, that is 1 times 2 3 plus 2 times 1 2 plus 3 times minus 1 1 plus 4 times 0 2, which will give us 2 3 plus 2 4 plus minus 3 3 plus 0 8. Now add corresponding terms and we will get 2 plus 2 minus 3 plus 0, and 3 plus 4 plus 3 plus 8, and we will get 1 and 18 again. So in both cases we got the same result. So if we multiply a matrix A with a column matrix, then we will get the same result in both ways. Our next topic is consistent and inconsistent system. Thanks for watching.